Hi folks, this is a quick video I'm making in response to a viewer request. He wanted to know how to connect all the different parts in a solar shed ventilation system. In my last video I didn't exactly show all of the details because I was trying to keep the video moving quickly. Typical YouTube fashion, you don't want to make it too long or no one will watch. But then if you leave details out, nobody knows what you're talking about. So here's the rest of the details. The most basic kind of solar shed ventilation setup is so unbelievably simple. You just take a solar panel, positive and negative, just like a battery. A solar panel is like a battery. It has a positive and it has a negative. And you want to know which one is which and connect that to the positive and negative wire of your car radiator fan. That's all you need. You don't need any electronics. You don't need anything complicated. I would recommend a switch. This car radiator fan has a black and a blue wire. I usually treat the black as negative and the blue as positive, and that will cause the fan to blow air in one direction only. Keep in mind, if you want to reverse the fan, that you will need to reverse the polarity in some cases. It depends on the car radiator fan, and you will also need to reverse the blade. But I usually use them as you see here. I just connect the positive here of the solar panel to the blue, and the negative of the solar panel will go to the black wire. That's literally all there is to it. The sun will shine, the fan will spin, and you need a 50-watt solar panel at least, because anything less than that, it's not going to turn the fan very fast. So 50-watt solar panel, 12 volts, is probably going to be the minimum. It's important to understand that really this isn't very complicated. A solar panel is a lot like a battery that the sun has to shine on, and on the back is going to be a label, and there's going to be what's called a junction box usually, and there might be some cables, there might not be. You know, you may have to connect your own wires. If you do need to connect your own wires, you just open up this box. It's called a junction box. Snap the cover off, take the screw out, and there will be a positive and a negative terminal inside that you can attach your wires to. But think of it like a battery that the sun has to shine on. There will be a label. This particular solar panel is only 20 watts. I'm using it as an example. It's a 12 volt, 20 watt solar panel. Again, I recommend a 50 watt to start with because, you know, you're not going to get a lot of power from a 20 watt panel. It's not going to do very much. A 50 watt, it will spin the fan enough to move some air, that's for sure. These numbers here are basically telling you how the solar panel will perform. Basically, this is a 12 volt solar panel, but the voltage at maximum power, which is right there, is 17.2 volts. However, these voltages are almost never accurate, and these are going to be all over the map, all over the place. What's probably going to happen is the voltage will be around 6 volts, 7 volts, 8 volts, depending on the size of the solar panel, because the fan is going to pull that voltage down to a really low voltage. So this big old giant fan on a 20 watt panel, you're not getting much of anything. It'll hardly turn. A 50 watt panel, it will absolutely turn if it's in direct sunlight, and you might get 6 volts. Doesn't really matter. This fan is doing you a favor by pulling the voltage down to something safe. 6 volts isn't going to burn this fan out. It'll probably run for years. I've had fans like this that ran year after year off of solar, no problem at all. I don't run them at 12 to 15 volts. I run them at around 8 to 10 volts, and they last a lot longer. If you're interested in a more complicated setup, there's also this option. This is a golf cart DC converter. These are very popular. They're all over the place. They're designed to take a higher voltage that could be anything from 20 to 50 volts and regulate that down to 12 volts. However, they have other voltages too, so you have to pay attention to pick the right one. These are a little more complicated. You have to connect your solar to the red and black. And you can see that that's a pair of wires coming out. Now, some of these do vary, and you need to pay attention to the instructions. This particular one that I've been buying, red and black, is positive and negative of the solar panel. So this is going to accept a higher input voltage. Usually there's a label that will tell you what the input and output is. Of course, this is all in other characters that we can't read, but generally speaking, you're going to put in about this much voltage and get about that much out. So it's about 12 volts out. What these are useful for is protecting your fan from over voltage. If you connect a 200 watt or 300 watt solar panel to a fan, you absolutely will burn that fan out. This will stand in between the voltage of the solar panels and the fan and ensure it doesn't get too high. Your fan would actually connect to the black and the yellow wires, in this case, on this particular golf cart converter. So you would need to find some way to connect these wires. You can use crimp connections, automotive crimp connections. You can solder them. And if you're adventurous, you can even use alligator clips, but those are a little bit risky and they might fall off. So use care. You don't want to short circuit and you don't want to cause a fire in your shed. That's how these work. These are not adjustable. Whatever voltage they put out, that's what they put out. You hook your fan up, you hook your solar panel up, this thing runs, and worst case scenario, you get, 6 or 7 volts. If the solar panel can put out 25 volts, then this converter will drop that to 12 volts and it'll never go over 12 volts. So it's like a safety gate to prevent the voltage from going over 12 volts. That's what this is. You could put 20 volts in, but 12 volts will come out. You can put 28 volts in, 12 volts will come out. It's a DC regulator or DC converter. Think of it like a safety valve for the solar panel to prevent the voltage from going too high and burning out the fan. If you want to use a pulse width modulation motor speed controller or PWM motor speed controller, those are connected in almost exactly the same way. You're going to have a positive input and a negative input, and you'll have a positive and negative output. Even though they don't actually convert the voltage, they just pulse it very quickly, they are connected in almost exactly the same way. So you could put your solar panel right into the input and your radiator fan right into the output. If you want to use a brushless DC fan, and I'm going to show you one here, this is my favorite in the whole world, brushless DC fan. This is not a cheap computer fan. This is a high power mining fan or server fan. As you can see, it's rated 12 volts at 2.7 amps. It's an SJ style fan. There's a lot of different SJ fans. Unfortunately, I can't tell you which one is best. This exact one I have here, you can see the picture of the label, works amazing. It works down to about 3.5 volts. Just amazing. I love this fan, and I now have it in 2 sheds, and I'm not going to change it. I love this fan. I bought several of them. The reason I like this fan is it's very well behaved, and it will run on as little as 3.5 volts. Some of the other fans are very picky, and they won't start unless you supply the right voltage. So not very good for beginners at all. Getting on to the DC converters, these are what you call adjustable DC-DC converters. Both of these I recommend, and I currently use them in my sheds. I really love this one. I think for a beginner, this is the one you're going to want to use. However, I'm going to show you, because my other videos did show this converter, this one's very confusing and it's not clear where to connect the power to. So I'm going to show you exactly where to do that. Your solar panel is going to come in right here. This is your positive, this is your negative, and it's got screw terminals. Those are not very fun to work with. So you got to get your wires in there and clamp them down with these screws. The board is not labeled in English, so for me, I can't really tell you what those characters say, but I know this is positive input and negative input. But you never want to reverse these two. If you put this in backwards, very high chance on a DC converter, if you hook negative up here and positive up here, it will instantly burn out. So be careful and observe positive and negative. And I would use red and black wires so you can keep track of which is which. The output, same thing. Positive here, negative here. You just connect your wires right there. This red LED will come on when you give this board power. So when you hook your solar panel up, you can go ahead and do that. To test the board, this red LED should come on. If it doesn't, turn the knob. It has a switch built in. The control is very sensitive, and it doesn't take much rotation to change the voltage. So I usually turn it really slow like this, and the voltage will start to come up. So turn it all the way to the left, it turns off. Turn it to the right, you hear a click. The board power is on, and the voltage starts to come up. So this will take a higher input voltage and output a lower voltage set by this knob here. This is a little bit more advanced. It's not necessarily beginner friendly. However, this board works really well if you have some air blowing on it. I set mine up where the air blows right here on these heat sinks, and it cools these chips, and it runs very well. This is in one of my sheds, and as far as I know, I'm going to keep it there unless I have a problem with it. The other board I recommend is this one. I actually really like this one, and it's in my other shed, and it's going to stay there. This is a little bit more beginner friendly, although it does look rather intimidating. This is also a DC-DC converter. It's a buck converter. It has an input and an output, which is labeled in English, in positive, in negative. This is where you attach your solar panels. You have screw terminals again, or you can plug it in this socket here. This is a 2.1 millimeter by 5.5 millimeter power plug. You can just connect that here, and this would be good for maybe 2 amps of current. It's not going to handle a very large solar panel, but a 50-watt solar panel with a little bit of air blowing over it to cool it is not a problem. Your output is right here, same thing, output negative, output positive. You connect your positive and negative wires of your fan here. Don't use this USB port. That's actually not a USB port. Now I'm going to show you how to connect a DC converter. If you're a beginner and have never used a DC converter before, then I'm going to show you exactly how simple it is. You need to identify the input. We know this is the input on this side. They also give you this socket. I'm going to use that because it's quick and easy. This plug goes to the solar panels that are attached to the wall of my solar workshop. They're actually outside, outdoors, and they put out anywhere from 10 or maybe 15 volts. It depends. It changes. And I'm just going to plug it right in. And you can see that it turns on. Now if you press the select button, you can get the output voltage and the input voltage. And that's why I like this DC converter. It can run small fans. It shows you the input voltage of your solar panel. That's right here. That's my solar panel connected through a wire. 9.95 volts. And it lets you see the output voltage. So constant current, I'm going to turn that up as high as it will go. I think that's high enough. You can't really tell, but I've turned this 4 or 5 times, and I know if I turn it to the right, that's turning it up as high as it'll go. Now I can turn the voltage down. You can see it changes the voltage. 2 volts. And the fan I'm going to show you running on this needs at least 3.5 volts to run. So I'll just set it to 3.6 volts, 3.8 volts. Now it has some other interesting features that I'm not going to go into. You should read the manual for this DC converter because it has a lot of cool features, but I'm going to quickly show you why I like this board. And the answer is because it also shows amps and watts. Very cool little board. If you don't overheat it and run it too hard, it should serve you well for many years to come. Now, how about a fan? DC-DC converters are excellent for running sensitive brushless DC fans. This is not an ordinary cheap computer fan. This is actually a server or mining fan. It has ball bearings and it needs a regulated supply of 12 volts. 12 volts here does not mean your car battery. Okay, this is a computer or server fan, mining fan, high quality, and it needs a regulated 12 volt supply. However, some of these fans are well behaved and will run down to 3 or 4 volts. This style of fan that I'm showing you on camera is my all-time favorite brushless DC fan. I have these in 2 different sheds. The reason is they accept a low input voltage and they don't stall when you do that. Other fans require a very high voltage. They may require as much as 6 or 7 volts or they won't start. This fan, no problem. Great for beginners, it works. However, put a fan grill on here because this can really injure your fingers. Don't try to operate this fan without a fan grill on both sides. And by fan grill on both sides, I mean this. Here's a 50-watt mining fan, extremely powerful fan. You don't want to play with this. It's not a toy. This is a 120 millimeter fan. You can see I've got a fan grill on both sides. That's to protect my fingers, and it will only take one mistake. If you put your finger in there, that's a problem. So always use a fan grill on the fan. However, because I know what I'm doing, I'm just going to briefly test this fan on the bench. It's a brand new out-of-the-box fan. I'm not going to stick my finger in there. I'm going to show you how to hook it up. This SJ fan has a 4-pin connector on it. However, you only need 2 of them. You need the black and the red, positive and negative. You're not going to use the yellow and blue. Those are for signaling the fan and controlling its speed inside of a computer or server. We're just going to feed it a straight voltage through the black and the red wire, which is negative and positive, and I'll show you how to do that. To make some temporary connections, I'm going to use these headers here. So what I'm going to do is I'm going to take the output positive, and I'm going to attach an orange wire to it. Tighten the screw down. And those are pretty easy to strip out, so be careful with them. For the negative, I'm just going to connect a brown wire because that's what I happen to have. I would rather use a black wire, but I don't have one, so tighten down the screw. Now it's a good idea to turn the output on and off. This particular DC converter has an on-off switch. You can see there's an LED that lights up when it's on. So that's on and that's off. That way I don't accidentally short out the outputs by crossing them over. Although it probably wouldn't necessarily cause a problem, you don't want to do that. It's bad practice. Now what I'm going to do is I'm going to attach the fan connector right here. So we're going to do positive, orange is positive. Temporary connection here to test the fan. And you're probably going to want to cut this connector off. Brown is negative, and there's how you connect the fan. You probably are going to want to cut that connector off and do a proper wiring job. For a bench test though, this is just fine. Now I'm going to check my polarity again to make sure I don't burn out my fan. So orange is positive, brown is negative on the output, right there. And on the fan, brown is negative, and then orange is positive going to the red wire, which is positive. So I just want to make sure because these brushless DC fans have a circuit board inside and can burn out if you hook them up backwards. So we got to make absolutely sure to get the polarity correct. Now we can test the fan. Okay, it's a bit risky testing the fan without a fan grill, but I have my solar panels going in. I'm getting 10.7 volts, and if I hit the select button once, the output is 0.01 volts because the DC converter is turned off. But I had already set it to around 3 or 4 volts, so let's just turn it on and see what happens. So I'll press the on-off button. Starts right up. 3.6 volts, it's able to run, it's able to start. Let's try turning the voltage up a little bit. That's where you turn the knob for constant voltage. Right there where my finger's pointing, constant voltage. Constant current I turned up as high as it would go already. I don't care too much about constant current. That's for another video another day. Turn it clockwise and you get more voltage. Let's try 5 volts. That's about 5 volts. Okay, 5.06 volts. Now this board is really amazing because you get to see how many watts you're getting. So you can hold the select button down for 5 seconds and the display will change to watts. 2.37 watts, not very much of course. However, there's a lot of air coming out of this fan. It's amazing how much air comes out. Hold it for 5 seconds. It's not exactly 5 seconds, it just takes longer. You hold it longer than you normally would. Amp hours. And amps. So 0.46 amps, 0.5 amps, about a half an amp of current is flowing through this board. And there's quite a lot of air coming out. Turn it off. So that's how you connect the DC converter to a fan, a brushless DC fan. Now what you don't want to do is take a big old giant fan like this and plug it into that tiny little DC converter. It's just not a good idea. And this fan here draws a lot of current, and really it's better suited for just running straight off a solar panel if you can get away with that. If you're able to handle DC converters, that opens the door to running these more sensitive brushless DC fans. Some of these might handle a higher voltage than what they say. However, you don't really know that, and if you run it on, say, 15 volts, it might run fine for a while and then burn up. And so when they put 12 volts on there, they mean 12 volts. And that's why you need a DC converter to safely and reliably operate these brushless DC fans. Keep in mind that these small DC converters here are not really suitable for handling a big fan like this. This fan could draw up to 6 to 10 amps under certain conditions. These DC converters can handle 2 or 3 amps at the very best with some cooling or air blowing over them. A PWM motor speed controller usually can handle a bit more current. It might be able to handle 5 amps. This small PWM motor speed controller you see here might be suitable for controlling a car radiator fan with a 50-watt solar panel. If you want to, you can also take your golf cart DC converter and run that into the speed controller and then connect the fan. That's rather complicated, and I don't recommend a setup like that for beginners. It's too complicated and too many things can go wrong. It really isn't necessary. If you want to use an adjustable DC-DC converter with a large fan, such as a car radiator fan, it can get a bit out of control. You would need a much bigger DC converter. Here's an example of a large DC converter. It costs much more money, and honestly, it seems kind of like a waste of money when you could just hook this fan straight up to a solar panel and it would work. If you're concerned about excess voltage, you can always use a golf cart regulator to protect the fan from excess voltage. Just a note about car radiator fans. Even though they say 12 volts on them, they can run on much less voltage. For example, this fan can run on as little as 5 or 6 volts and it still moves a decent amount of air. It depends on the size of your shed. If you run this fan for extended periods of time at 12 volts or above, it gets extremely hot. In fact, this motor here will get too hot to touch, and very soon it will eventually burn out. And in fact, these wires here may even melt off and it could catch fire. Car radiator fans like to run at around 6 to 8 volts, and that way they get pretty hot, but they don't get too hot. If you just hook a 50-watt solar panel up to it, you probably will get about 6 volts, and that's pretty good. It'll move some air. It's very simple technology. It's very robust. You don't have to configure anything. You don't need a DC converter, and that's why I like to recommend them. If you're a beginner, I emphasize again that it's better sometimes just to pick the simple solution: 50-watt solar panel, car radiator fan, put it in your shed and see what happens. You can learn by doing, and that's actually how I learn. Pros and cons of brushless DC fans versus car radiator fans. I actually like both solutions. If you're a beginner and you're not really sure what a DC converter is, or you're not familiar with them, probably best to just take a solar panel and a car radiator fan and just try that out for a while. If you're somebody who knows something about electronics, you have some electrical knowledge of some sort, and you're looking to add to that knowledge and learn more, brushless DC fans could be considered more efficient and also can be more interesting to work with. You can introduce a DC converter and you can have a lot more control over how the system behaves, how it works, the speed of the fan, and so forth. If you're going to use a brushless DC fan, I do recommend this particular model here. If you can get the exact same fan, I know this fan to be working extremely well for solar-powered shed ventilation systems. And as far as I know, I'm going to be using this fan indefinitely. I do have other fans that I've experimented with, and I'll show you an example. By the way, these are all 120 millimeter brushless DC fans. So they're 120 millimeters across, and they're quite a standard size. You can find these everywhere. They are not normal computer fans, which usually don't move a lot of air. This fan in particular is an example of a very powerful fan that requires about 50 watts of power to run. Unfortunately, it does not accept a lower input voltage and demands a higher input voltage, or it will not start properly. So this fan is useful in more powerful setups with a large solar panel. With a 50 watt solar panel, this particular fan here should run just fine. It will run at around 7 to 8 to 9 volts, and it depends on the amount of sun on the panel. It runs very smoothly, and if the sun goes behind a cloud, what will happen is this fan will just gracefully slow down and continue moving air until the sun comes back out. Some fans, such as this fan, if the sun goes behind a cloud and you lose voltage, it will start doing strange things, including stuttering. It will stop and start, and generally it'll just be really annoying. So a fan like this would only be useful with a large setup with large solar panels and a powerful DC converter that can maintain at least 6 volts so that the fan can continue running properly. In actuality, this particular fan required almost 7 volts before it would run properly and reliably. I hope this video helps you out in your solar shed ventilation project. Please be sure to check out my previous videos on the subject that are linked in the description. If you have any questions, please let me know. Thanks for watching, and see you next time.